Hi everyone, welcome back to Math 245. Hope you had an excellent weekend. On Friday of last week, we talked about how to compute probabilities with permutations. That's when order matters. And the first of the two lessons that we are talking about today is how to compute probabilities with combinations. So combinations is when order does not matter. So let's do a few examples here. It's going to look pretty similar to permutations, except our formulas will be slightly different. So assume, for example, that a store has 8 cell phones and 3 of those are defective. Not a good store. We might want to find the probability that a couple purchasing 2 phones receives 2 phones that are not defective. So if I have 3 phones that are defective, that means that 5 phones are not defective. So I want to compute the probability that I choose 2 phones from 8 that are working. So here's how we do that. This probability is equal to, well, first of all, how many ways can I choose 2 phones that aren't defective? That will be the number of ways that I can get what I want, right? I want 2 phones that aren't defective. So I first need to figure out how many different ways are there to select 2 phones that aren't defective. So ways to select 2 phones that aren't defective. So this is the pool of possibilities that I want. And then I have to divide that by the total number of possibilities, right? So I'm choosing 2 phones from 8. So I have to divide this by the number of ways to select 2 phones. Well, if I look at the top here, the ways to select 2 phones that aren't defective, I have 5 phones that aren't defective. So this is choosing 2 from 5 that aren't defective. So this is C5, choose 2. And then on the bottom, I am selecting 2 phones from 8. So that will be C8, choose 2. So let's see. C5, choose 2 will be 5 factorial over 3 factorial, 2 factorial. And then I divide this by 8 factorial divided by 6 factorial, 2 factorial. That's C5, choose 2 over C8, choose 2. Okay, well, simplifying this a little bit gives me 5, 4, 3, 2, 1 over 3, 2, 1 times 2 times 1 over 8 times 7, 6, 5, 4, 3, 2, 1 over 6, 5, 4, 3, 2, 1 times 2. All right, let's see how we can simplify this. So I can simplify the top by canceling out these 3 2 1s. And if I cancel this 2 with this 4, I'll be left with a 2. So total I have 10, right, 5 times 2 on top. And what about the bottom? Well, I can cancel the 6, 5, 4, 3, 2, 1. So I am left with 8 times 7 on the top. If I cancel out this 8 with this 2, I'll be left with 4. So I have 4 times 7, which is 28. So the chances that I select 2 phones that aren't defective is 10 out of 28. which is not really a great chance, so I would go to a different phone store. So again, here we needed to figure out how many different ways I select 2 phones that aren't defective and divide that by the total number of ways to select 2 phones. Okay, let's do a couple more examples here. A class has 25 students and it has 12 freshmen and 13 sophomores. If a random group of 5 students is selected, what is the probability that they will all be sophomores? Okay, well, I need to compute the total number of ways to pick 5 sophomores and divide that by the total number of ways to pick 5 people. So this will be the ways to pick 5 sophomores divided by the ways to pick 5 students. All right, well, on the top here, I'm choosing 5 sophomores from 13. So this is C, 13, 5, since I have 13 sophomores in this class and I want to choose 5 from them, divided by the ways to pick 5 students. This will be C, 25, choose 5. All right, let's do this math off to the side here. So let's first do 13, choose 5. Well, this is 13 factorial divided by 5 factorial, 8 factorial. That will be 13 times 12 times all the way down to 3 to 1 over 8 times 7 times 6 times all the way down to 1 times 5 times 4 times 3 times 2 times 1. Okay, well, if we can imagine, I didn't write all the numbers out because there were a lot, but I can cancel the 8, 7, 6, 5, 4, 3, 2, 1. And I'll be left with 13 times 12 times 11 times 10 times 9 over 5 times 4 times 3 times 2 times 1. Okay, let's see how I can simplify this a little bit. I can see that if I cancel out this 5 and this 2, that's 10. So I can cancel out that 10 here. And then if I cancel out 4 and 3, well, 4 times 3 is 12, so I can cancel that out there. So I have 13 times 11 times 9 over 1, and that is 1,287. So there are 1,287 different ways to pick 13 from 5. Next, I need to look at the bottom here. So far I have 1,287. And now I need to look at 25, choose 5. Whoops, I didn't write that down right. So this is 25, choose 5. Is equal to 25 factorial over 5 factorial, 20 factorial. So I imagine that if I were to cancel out the 20 factorial with the 25 factorial, or with the 20 factorial on top, then I would be left with 25 times 24 times 23 times 22 times 21. That would be on top. And then on the bottom, since I canceled out that 20 factorial, I'd be left with 5 times 4 times 3 times 2 times 1. Okay, let's see what I can cancel out here. Well, if I cancel this 5 with this 25, I'll be left with a 5 on top. And 4 times 3 times 2 is 24. So I can cancel out this 432 with this 24. So I'll be left with 5 times 23 times 22 times 21, which is 53,130. So there are 53,130 different ways to pick 5 students from 25. So if I were to divide this, 1,287 divided by 53,130, I am left with 0.024. So that is something like 2.4%. Not very likely, but still a possibility. So here we had to divide the ways to pick 5 sophomores divided by the ways to pick 5 students. All right, the next problem is a little bit different. We have a bowl of mixed nuts, contains 5 cashews, 6 almonds, and 12 peanuts. If Bob pulls out 7 nuts, what is the probability that he will get 5 peanuts and 2 almonds? So here we have 2 things we're looking for, right? Here we have that we want 5 peanuts and we want 2 almonds. So my probability here is the ways to pick 5 peanuts and 2 almonds divided by the ways to pick 7 nuts. All right, so first of all, how many nuts do I have total? Well, I have 5 cashews, 6 almonds, and 12 peanuts, so that is 23 total. But so on the top here, I have 5 peanuts and 2 almonds. So I want 5 out of 12 peanuts. So the ways to pick 5 peanuts is to say C of 12, choose 5, since there are 12 peanuts. And I want to choose 2 almonds. So the way that I combine these 2 things is I multiply these probabilities together. Times C, I want to choose 2 almonds from 6, so that is C6, 2. So again, the way that I combine when I want to pick 2 separate things is through multiplication. Divided by the ways to pick 7 nuts, that is C23, choose 7. All right, so let's do the math here on the side. So C12, choose 5. How many different ways are there to pick 5 peanuts from 12? This is 12 factorial over 7 factorial, 5 factorial. If I cancel out that 7 factorial from the top and the bottom, I get 12 times 11 times 10 times 9 times 8 over 5 times 4 times 3 times 2 times 1. Well, I can cancel out the 5 and the 2 with the 10, and the 4 and the 3 with the 12. So I'm left with 11 times 9 times 8, which is 792. That's C12, choose 5. If I want to look at C6, choose 2, this is the almonds. This is 6 factorial over 4 factorial, 2 factorial. If I cancel out that 4 factorial, I'm left with 6 times 5 over 2, which is 15. So there are 15 ways to choose 2 almonds from 6. And finally, I need C23, choose 7. This is 23 factorial divided by 7 factorial, 16 factorial. If I cancel out the 16 factorial from the top and the bottom, I'm left with 23 times 22 times 21 times 20 times 19 times 18. Oh, I'm running out of room. Let me rewrite this. Smaller. 23 times 22 times 21 times 20, 19, 18, 17. Over 7 factorial. 7, 6, 5, 4, 3, 2, 1. Okay, let's see what I can cancel. If I multiply 6 times 3, that's 18. Let's see, what else? 5, I'll do 5 times 4, and that's equal to 20. And then I will, if I cancel out this 7 with this 21, I'll be left with a 3 on top. And if I cancel this 22 with this 2, I'll be left with 11. So this is equal to 23 times 11 times 3 times 19 times 17. So 23 times 11 times 3 times 19 times 17 is a very large number, 245,157. Okay, so putting this all back into our equation over here, I saw that C of 12 choose 5 was 792. C6 choose 2 was 15 over 245,157. So if I were to divide this, well, first let's multiply. So 792 times 15 is equal to 11,880 divided by 245,157. So 245,157, this is 0.048, which is 4.8%. Ooh, so this is a lot of number crunching, doing these factorial stuff, canceling things out. But hopefully you get the general gist of these kinds of problems. All right, this was the first of 2 lessons, so go on over to lesson 36. I'll see you there.